In this lesson, we'll be factoring polynomials. We're going to be doing this with the greatest common factor method. So, what is factoring? To refresh our minds, it is the process of rewriting an expression as the product of an expressions. So when we're factoring a polynomial with a GCF, our first step is to look for the GCF of the coefficients. Our second step will be to look for the coefficient of the variables. The GCF of the variables will always be the variable with the lowest exponent. And then step 3 will be to divide each term by the entire GCF. This polynomial will be the second factor and go in parentheses. If, while we're factoring, the greatest common factor of the polynomial is 1, then we would call the polynomial prime. Okay, so let's go ahead and actually look at some examples and put all of these steps into practice. So for our first example here, we see 5x squared plus 10x. So we're going to look at the coefficients first, the 5 and the 10. And between the 5 and the 10, the greatest common factor is 5. Great. Then we'll look at the variables. We have an x squared and an x to the first. So the lowest variable exponent is just x. So 5x is our GCF. We're going to write that down first, and then we open parentheses. So to figure out what's left over, we're going to divide each term in the original expression by our GCF. So if we divide 5x squared by 5x, 5 divided by 5 is 1. X squared divided by x is just x. We'll bring down our sign from before. There was a plus there. 10x divided by 5x. Well, 10 divided by 5 is 2. And the x's completely cancel out. So now we have a product. 5x times x plus 2. We have factored the original expression. And that's our final answer. We might also be able to do this when we have a trinomial. So if we look at the expression 14x cubed plus 21x squared minus 35x, we need to look at all three terms to find the GCF. So between the coefficients, 14, 21, and 35, we can pull out a 7. If we look at the variables, we have an x to the third, x to the second, and x to the first. So we can only pull out x to the first. That's our GCF. We open parentheses. 14 divided by 7 is 2. We took away 1x. We have an x squared. Bring down our plus sign. 21 over 7 is 3. We took away 1x, so we still have 1 left over. This time we have a minus to bring down. 35 divided by 7 is 5, and no x's are left. So that is the factored expression. Let's do one more here together. 54x to the 7th plus 45x to the 5th plus 81, or minus 81x to the 3rd. Okay, let's look at the three coefficients. And the greatest common factor of all three of those is 9. And if we look at the variables, the lowest power there is to the third power. So that's our GCF. When we go ahead to factor that, 54 divided by 9 is 6. We took away 3 x's, so we have x to the 4th, plus 45 divided by 9 is 5. We took away 3 x's, so x squared, minus 81 divided by 9 is 9, and there are no x's left over. Terrific. So that's how we factor polynomial expressions by pulling out a greatest common factor. Again, watch out for an example where there might be nothing to pull out because in those examples, they will be prime. One thing to watch out for, though, is let's find an expression, yes, like number 11. In number 11, we start with a negative. So when the leading term, the term with the highest degree, starts with a negative, it's going to be our preference to factor out a negative number. So between negative 35 and negative 98, they both have a factor of negative 7. There's no x's in common, so it's just a number that is the greatest common factor. So when we go into parentheses now, negative 7 times positive 5 would give us negative 35. We still have our x to the 4th. And now we did have a negative, but now we're going to have a positive there. And negative 7 times positive 14 would give us negative 98. So that's how we handle an expression when the leading coefficient is negative. Thanks so much for watching, everyone, and hope to see you again next time.